All right, welcome everyone. Today we are unpacking an urgent, highly critical threat intelligence briefing on a campaign known as WP2Shell. If you manage web infrastructure, or frankly, if you just want to understand how modern, large-scale cyber attacks unfold in the real world, you are in exactly the right place for this explainer. We're going to break down the anatomy of this critical WordPress exploit step by step so you can grasp the mechanics and, more importantly, the mitigations quickly and effectively. Okay, let's dive right into this. 60%, according to scan telemetry from Wiz Research, at the exact time this vulnerability was disclosed, roughly 60% of organizations running WordPress had at least one vulnerable instance. And it gets worse. About 25% had a vulnerable instance directly exposed to the open internet. So we aren't talking about some niche theoretical threat here. We are talking about a massive global attack surface. To efficiently unpack all of this, we're going to follow a highly structured agenda today. We'll start with an overview of WP2Shell, then look at how the exploit actually works, run through the real-world timeline, cover the specific indicators of compromise to hunt for, and wrap up with impact and mitigation. Starting with Section 1, Overview of WP2Shell. What exactly is this beast? Well, WP2Shell is basically a two-vulnerability exploit chain. It strings together CVE 2026-603030 and CVE 2026-6037. But honestly, the absolute most critical part of this definition is the phrase unauthenticated remote code execution in WordPress Core. This means an attacker requires zero authentication. None. They don't need a username, they don't need a password, and crucially, they don't need you to have some random vulnerable third-party plugin installed. This flaw exists entirely within the default WordPress core code itself. What's genuinely wild here is how the broader security community had to react. The WordPress project actually overrode site owners' auto-update preferences to force push emergency patches to all supported installations. You know, that is an incredibly rare step, and it really highlights the sheer urgent severity of the issue. On top of that, this exploit chain was immediately slammed onto the CISA Known Exploited Vulnerabilities, or KEV, catalog. It is literally the very first WordPress core pre-auth RCE to ever make that list. Moving on to Section 2, how the exploit works. Let's de-jargonize this complex chain. You can think of this exploit kind of like picking a lock to rob a safe. Step 1 involves the attacker sending a malformed request to a very specific REST API endpoint, the batch route. Because of a logic flaw in the code, this causes what's called route confusion, which leads directly to Step 2, completely bypassing the API's normal authorization checks. It's essentially picking the outer lock of the building. Once they're inside, Step 3 kicks off. The attacker leverages a SQL injection vulnerability inside a parameter called author_not_in to crack the internal safe. This lets them read the database directly, leading to Step 4, stealing administrator credential hashes, logging themselves in, and uploading a malicious PHP web shell that's cleverly disguised as a plugin. And the entire flow is remarkably elegant from an attacker's perspective. It starts with just an anonymous HTTP post request. That route confusion bypasses the authorization, which immediately triggers the SQL injection. From there, the attacker extracts the admin password hash, escalates to remote code execution by dropping a fake plugin zip file, and finally establishes persistent backdoor access with a token-gated web shell. It's a highly efficient, fully automated chain from start to finish. Let's look at Section 3, the real-world exploitation timeline. Just how fast did this spread? We are talking about an incredibly compressed sequence of events here. The vulnerability was officially disclosed and patched on July 17th. By July 18th and 19th, less than 48 hours later, mind you, defenders were already seeing active exploitation attempts hitting their honeypots, and there were over 24 distinct proof-of-concept exploits circulating publicly. By July 19th and 20th, full remote code execution in the wild was absolutely confirmed. This 48-hour window from patch release to active mass exploitation proves that the old, we'll patch it next week during the maintenance window mentality, yeah, that just doesn't fly anymore. And I want to be clear, this isn't just isolated data from one source. Multiple independent threat intelligence and security vendors, including Hexastrike, PatchStack, Wiz, Watchtower, and VulnCheck, all neutrally corroborated these live, in-the-wild intrusions. So the consensus across the security industry leaves absolutely zero doubt about the active, widespread nature of this threat. Section 4, Indicators of Compromise. If you're defending a network right now, what exact footprints should you be hunting for? So the crucial point is knowing the specific patterns these attackers leave behind. On the network side, you really want to be looking for anomalous post requests to the /wp_json/batch/v1 endpoint, particularly any requests containing SQL keywords inside that author_not in parameter. Then, on the file system itself, keep an eye out for fake, unrecognized directories just hiding inside your WP content/plugins/folder. And finally, audit your user accounts for rogue administrators using a very specific naming convention. They typically use something like WPSVC followed by a random hex string. To make this even easier to spot, here are a few more highly specific forensic details to keep in mind. These automated mass scanners are using distinct user agents like WP2Shell check/1.0 or WP2Shell POC/1.0. Also, the network traffic might actually show a multi-part form boundary prefixed with ... WP2Shell. If they do successfully breach the server, they tend to drop tiny PHP web shells, often just 1 or 2 kilobytes in size, that feature a forged author WordPress.org community header just to blend in. Remember, these are the classic hallmarks of opportunistic automated scanning scripts. Finally, Section 5, Impact and Mitigation. What happens if this succeeds, and how do we stop it dead in its tracks? The business impacts of a compromise here are severe. We are way beyond a simple website defacement. A successful WP2Shell exploit means a full administrative takeover and direct read and write access to your underlying database. Attackers can inject SEO spam, expose your visitors to drive-by malicious content, and potentially trigger massive regulatory and breach notification nightmares depending on what data you hold. Plus, your server can actually be hijacked and repurposed as infrastructure to host malware or scan for other vulnerable sites. It's the whole shebang. Okay, please pay close attention here because this is the absolute most crucial takeaway for defenders today. If you are running versions 6.9.0 through 6.9.4, you must patch to version 6.9.5 immediately. If you're on 7.0.0 or 7.0.1, you must move to 7.0.2 to break the full RCE chain. And definitely note that older 6.8 branch, it is still vulnerable to the SQL injection component of this attack. So if you are on 6.8.0 through 6.8.5, you absolutely still need to update to version 6.8.6. Now, beyond just hitting update, here is a quick summary of the required hardening steps. First off, do not blindly trust that the forced auto-update worked. Manually verify that your version number has actually changed. If you literally cannot patch right this second, you can deploy Web Application Firewall, or WAF, rules to filter malicious post requests to that batch endpoint. But remember, WAF rules are only a temporary band-aid. The ultimate permanent solution is patching. Finally, restrict anonymous access to your REST API if your site doesn't actually need it, and actively audit your admin accounts and plugin directories for the anomalies we discussed earlier. If you suspect you might have already been targeted, the incident response workflow is pretty straightforward. Phase 1 is detection, checking your versions and grepping your logs for those IOCs. Phase 2 is containment, blocking the malicious paths at your proxy or your WAF. Phase 3 is eradication, getting that core patched, deleting any rogue admins, and stripping out those tiny web shells. Phase 4 is recovery, restoring from known clean backups and rotating all your credentials and keys. And finally, Phase 5 is learning, preserving your logs and making absolutely sure your auto-updates are firmly in place moving forward. So we've covered the mechanics of the exploit, the rapid 48-hour timeline, the specific indicators to hunt for, and the vital patch versions. I want to leave you with this stark thought as we wrap up this explainer. With global, opportunistic mass scanning already aggressively underway right now, is your WordPress instance truly patched and monitored, or is it just a ticking clock? Thank you so much for learning with me today. Take this information, double-check your environments, and stay secure out there.